Imagine the deep space, a dark and seemingly silent ocean, where billions of stars shine like distant beacons. Among them, immense structures called galaxies slowly drift across the universe. Each galaxy contains hundreds of billions of stars, planetary systems, nebulae, and supermassive black holes. Now picture two of these colossal entities, each larger than anything our minds can truly comprehend, traveling toward one another in an inevitable and slow cosmic ballet. What happens when galaxies collide? Is it the end of everything we know, or just the beginning of something even greater? Contrary to what many imagine, a galaxy collision is not. Like a car crash at high speed, there is no sound, no instant cinematic explosions, no total destruction. Space is so vast that despite containing trillions of stars, the chance of two of them colliding directly is almost zero. What really collides are the gravitational fields, invisible forces that begin to distort and reshape each of these cosmic structures. As two galaxies draw near, their gravitational fields intertwine, spiral. Arms begin to stretch like threads of an invisible web. Being pulled, nebulae are compressed, and entire systems may be hurled out of the galactic disk. It is a silent war where the most powerful weapon is gravity. This process does not happen over days, months, or years. It takes millions, even billions of years to complete. It is like watching a film in extreme slow motion, where each frame lasts thousands of human generations. But for the universe, it is just another natural cycle of transformation. Even without stars colliding, the effects are colossal. Gravitational fields. Warp stars are flung into distant regions while others drift dangerously close. Gas clouds collide, triggering bursts of star formation. Cosmic fireworks illuminating the darkness. Supermassive black holes located at the center of each galaxy begin a gravitational dance that can last millions of years until they finally merge in one of the most energetic events in the cosmos, a black hole merger, releasing gravitational waves that ripple through the fabric of space-time. It is important to understand that galaxy collisions are not rare events, but rather natural stages in the evolution of the universe. The Milky Way, our cosmic home, has already absorbed several smaller galaxies, devouring dwarf galaxies that strayed too close. And in the distant future, an even greater spectacle awaits us, the inevitable collision between the Milky Way and Andromeda, our closest neighbor. Will this be the end of Earth, or merely the transition to something new, a redefinition of our cosmic home? When two galaxies begin to approach, the first visible manifestation of this cosmic dance is gravitational distortion. There is no exact moment of impact as we are used to imagining with terrestrial collisions. Instead, as they draw closer, their gravitational fields begin to interact, creating cosmic tides, just as the moon pulls on Earth's oceans, causing tides. Approaching galaxies pull on each other, distorting their shapes. Picture the Andromeda galaxy stretching the arms of the Milky Way as though pulling threads of an invisible fabric. The once orderly spiral arms begin to elongate, twist, and form structures called tidal tails. These tails can extend hundreds of thousands of light years, forming vast streams of stars, gas, and cosmic dust. In these distorted regions, something remarkable happens. Gas clouds violently compress, triggering bursts of star formation. New stars are born in massive quantities, lighting up parts of the galaxy like celestial fireworks. It is one of the universe's ironies. While ancient structures begin to unravel, new cosmic life emerges, a demonstration that destruction and creation walk hand in hand. But the spectacle is not just luminous. Planetary systems can be shifted from their stable orbits. Stars peacefully orbiting the galactic center can be hurled into intergalactic space, becoming rogue stars. Others may be forced into dense regions, increasing the chances of close stellar encounters. And at the heart of the galaxies, the supermassive black holes wait. Still far apart, they begin to feel each other's pull. Each one carries with it an entourage of stars orbiting around its core, and their slow approach creates perturbations that accelerate chaos on a colossal scale. This first contact can last hundreds of millions of years. For us, living on such a short timescale, it is impossible to imagine such slowness, but if we could speed up time, we would see two gigantic entities approaching, stretching luminous arms and firing jets of newborn stars like torches, glowing in the dark. At this stage, the galaxies still retain their identities, but they are no longer the same. They have been touched by the presence of the other, marked forever by an inevitable destiny, fusion. After first contact, the galaxies enter a prolonged state of chaos. Their original forms begin to disappear, replaced by distorted structures, like lumps of clay being molded by invisible hands. They collide, pull apart, then draw back together in cycles that may repeat several times before the final fusion. Each encounter unleashes shockwaves that sweep through interstellar clouds, compressing gases and creating new bursts of star formation. These stellar booms can quickly consume the galaxy's gas reserves, leaving them older and drier in the future. Newborn stars light up the galaxies like blazing torches, but not all have peaceful destinies. Many form in unstable regions, where gravitational forces compete violently. Some may be ejected soon, after birth, condemned to wander space without a galaxy to call home. Meanwhile, in the core, the supermassive black holes inch closer together. They orbit in tightening spirals until merging becomes inevitable. When it does, they release a colossal amount of energy in the form of gravitational waves, ripples in the very fabric of space-time, capable of traversing the universe. It is in this middle stage that the collision reaches its peak of aesthetic beauty. Merging galaxies create breathtaking images, captured by telescopes such as Hubble. Structures resembling cosmic flowers, with petals of stars glowing in the dark, show that, even in chaos, there is beauty. But for any civilization within one of these galaxies, the experience would be filled with uncertainty. Nearby stars might pass dangerously close, altering planetary orbits. The night sky would become a spectacle of shifting lights, with nebulae appearing and vanishing, entire constellations dissolving within a few generations. This is the most turbulent and transformative stage of the collision. It is here that the old galaxy begins to die, and a new galaxy begins to take shape. After billions of years of dance, of approaches and retreats, comes the moment of final fusion. At this stage, the galaxies are no longer independent entities. Their cores collide, and their supermassive black holes merge in a cataclysmic event. This merger releases energy comparable to billions of stellar explosions, though spread out as gravitational waves that ripple silently across the universe. The new galaxy born from this union rarely retains the spiral form of its predecessors. The turbulence destroys the delicate structure of spiral arms, and the result is usually an elliptical galaxy, more rounded and less defined. These galaxies tend to be older, with less gas available for star formation, glowing with the reddish light of aging stars. Yet the spectacle does not end there. During the fusion, stars can be flung at incredible speeds, becoming hypervelocity stars that escape the gravitational pull of the new galaxy and embark on solitary journeys through intergalactic space. It is as though fragments of memory from the old galaxies are scattered across the cosmos. For us, living in the Milky Way, this reality will inevitably arrive. In about 4 billion years, our galaxy will merge with Andromeda, forming a new cosmic entity. Many scientists believe that the Sun may survive this event. though its position within the galaxy will surely change. The night sky on Earth, if life still exists here, will transform into a spectacle of moving lights, with Andromeda dominating much of the horizon before fully merging with the Milky Way. This new galaxy already has a predicted name, Milkdromeda, a fusion of identities, a symbol of the endless cycle of destruction and rebirth of the universe. The collision of the Milky Way with Andromeda raises a fascinating question. What will the impact be for humanity if we still exist in that distant future? Despite the visual spectacle, life on Earth will likely face no immediate danger. As we have seen, stars rarely collide. The real risk lies in gravitational changes that could alter planetary orbits or bring neighboring stars too close. But space is so vast that the odds of the Sun suffering a fatal disruption are minimal. However, the night sky will be radically different. Imagine looking up and seeing Andromeda covering almost the entire horizon, a luminous arc stretching across the heavens. Over millions of years, we would see stars crossing the sky in unexpected directions, familiar constellations dissolving and new patterns forming. For an advanced civilization, this cosmic transformation could become a cultural milestone. Perhaps future peoples will tell stories about the day the sky began to change or create mythologies around the merging of galaxies. But there is also the question of the supermassive black hole. When the Milky Way's black hole merges with Andromeda's, the energy released could briefly create a quasar, a cosmic beacon radiating immense amounts of energy. Depending on Earth's position, this could have significant effects on the atmosphere and perhaps on life itself. This fusion might also shape the future of space exploration. If humanity has spread among the stars, by then we could witness the creation of a new galaxy firsthand. Colonists on distant star systems would observe the spectacle from different perspectives, making the experience even more varied. In the end, the Milky Way-Andromeda collision will be both a challenge and an opportunity. For intelligent life, it will be a chance to witness one of the greatest cosmic events of all time, and perhaps to better understand our place in the universe. When we think about galaxies colliding, our human minds tend to associate it with destruction, yet the universe teaches us something very different. Collisions are also moments of creation. Stars are born, new galaxies emerge, and black holes merge, releasing energy that reshapes the cosmos. This eternal cycle of death and rebirth is a powerful reminder that nothing in the universe is static. Everything is in motion, everything is changing, and even colossal structures like galaxies are destined to transform. For us, small inhabitants of a blue planet orbiting an ordinary star, these changes may seem beyond our comprehension, but in a way they reflect our own existence. Just like galaxies, we too go through cycles of transformation. The end of one phase is always the beginning of another. The collision of galaxies is not the end, but a new beginning, a cosmic metaphor reminding us that even amid chaos and uncertainty, there is always room for creation, renewal, and the birth of the new. And when the Milky Way finally merges with Andromeda billions of years from now, humanity may no longer exist to watch. But if we do, we will witness the greatest spectacle the universe can offer. And we will understand then that we are part of a much greater story, as a story written in the stars. Just as the universe reinvents itself in the midst of chaos, we too have the power to be reborn amid our struggles. The end is never truly the end. It is merely the beginning of something different, perhaps even greater. Thank you for watching this video. Please subscribe to our channel and like this video. Also, turn on the notification bell so you will be alerted to our posts. See you in the next video.